I want to review real quickly circuits and a little bit about how to do them. And let's say we have 3 light bulbs in a circuit, 7 ohms, 10 ohms, and another 7 ohm, and then let's say that there's a 25 microfarad capacitor and it's a 50-volt battery. And if we turn this on and let it go for a long time, it'll reach something called steady state, which means that the capacitor is completely charged, and you know when it's completely charged, it's like an off switch. In other words, current will not flow through this section, so it'll only be flowing through the light bulb parts after a long time. So I'm going to color code this, and this is the positive side, so we're going to make the positive side red, right, to that battery, not battery, from the battery to that light there. And then the negative side we're going to make blue. That's the lowest pressure, or what we call potential. That's going to go to there, and that's going to go to there, and there's not going to be anything flowing through here. So then what do we do with the middle part? I don't really have yellow. Let's see if this yellow here works. Yeah, it does. It's kind of big. So we'd have yellow to there, and we'd have yellow to there, and again, there's nothing really happening over here. No current flowing whatsoever. So I'm thinking about what to do here. I think we go ahead and color this in, but this would be no current whatsoever. So really the pressure, anyway, there won't be anything going through here, no matter how we color it, because it's already at steady state. So which light bulb would be brightest? Well, from red to yellow is a jump, and then yellow to blue is the same jump. The problem is this is a higher resistance, so this one will be less bright. So let me see here. So this one will be less bright. This will be the least brightest because it's got the most resistance, and most of it's going to flow through. So it's going to flow through this one. It has to flow. This was in series with these two, which are parallel with each other. And so this one's going to be the brightest because it's the first one. So this is the brightest. And then this right here would be second brightest. Second brightest. And so what would I do here to, and that's just doing the color coding and knowing that these two are different, and the one with smaller resistance is going to let more current through, and then the most current's going to go through this one, and this one's going to let less current through. All right, so bright, this would be the brightest, next brightest, the least brightest would be the 10 ohms. So if I wanted to find the, let's say I wanted to find the equivalent resistance or the total resistance. So I'm going to start with the 10 and the 7, and that's 1 divided by 10 plus 1 divided by 7. Hit x to the negative 1, and that gives me 4.1 basically. I'll just round off to 4. So this is 4 ohms, and this is still 7 ohms. And then this is going to go to the 50-volt battery. And of course we have our capacitor out here. That doesn't matter right now because it's full. It's full of charge. Alright, and then I'm just going to add these two together. And so let me extend the page. So my total resistance would be 11 ohms. And this would be 50 volts. And then we got our capacitor out here. fully charged. So my current would be V over R, which would be 50 volts over 11 ohms, which is going to be 4.5. So my total current is 4.5 amps. And then what's the current through this one? That's going to be, remember, current's the same in series. That'll be 4.5 amps. This will also be 4.5 amps. And then what happens to the current here is it splits up, so we have to know the voltage. Well, the voltage here, let's do this in a different color. The voltage on this one would be V equals IR. And so I already know current is 4.5, and I know the R is 4, so that's going to give me 18. So voltage here is 18 volts. So now I can figure the current out here, which is I equals V over R. So it'd be 18 divided by 7, and 10 divided by 7. So I'd have 2.6 amps for this one. And this one would be 1.4 amps. As you can see, again, that's through, that this has the most current, so it's the brightest, and this is the next brightest, and that's the third. But we did that real quick with our color coding. And then what if I wanted to know how much charge is on this 25 microfarad capacitor? Well, we know that charge equals C times V. And so what's V? Well, V on this 25 microfarads is not 50, it's actually 18. So it's kind of tricky because whatever the voltage for this is, that's going to be the voltage for that, the capacitor. So it's going to be 18 volts times 25 microfarads. I multiply those. I can just do 25 times 18. That gives me 450 microcoulombs for the total charge. And let's say that I wanted to, and so then let's say I wanted to add an ammeter in here to find the current of in this 10 ohm resistor. Where would I add it? Well, remember, ammeters go in series, so it would be added in series with the 10 ohm. If I wanted the 7 ohm, I'd add an ammeter in series. What if I want to know the voltage for the 7 ohm? Well, remember, voltmeters, circle V, are always in parallel, so I'd have it across like that. And that voltage would read, we'd have to figure it out, V equals IR, so it would be 4.5 times 7, which would be 31.5. You add those together, you get basically 50. So that is how you do a problem like that. If I was to change this and make this bigger, would it change how much charge is on this? And yes, it would, because the voltage would change on this. A bigger resistor makes a bigger voltage on, because it would make this somewhat bigger. So that's how you do a problem like that.
So